Hi guys, welcome to Science Teaser. This is Sudarshan Kasha with you. Let's see how to calculate the shear force and bending moment for a simply supported beam. Here the point A is supported by a roller support and B as well. Let the reaction force at A be RA, B be RB. I'm taking them to be upwards, you can take them downwards. Now I'm choosing upward forces as positive and downward forces as negative. There's a 2 kN force acting at C, 4 kN force acting at D. The separation between A and C is 1 meter, D and B is 1 meter. Overall span of the beam is 2.5 meters. Now let's put this aside. To calculate the bending moment and shear force, first we need to know the values of RA and RB. So applying equilibrium conditions, sigma MA is 0, that is moment of all these forces about point A must be 0, which implies RB into 2.5 is equals to 4 into 1.5 plus 1 into 2. So we get the value of RB now. RB is 3.2 kilonewtons. So RB is 3.2. Now applying equilibrium conditions, balancing the upward and downward forces, we have RA plus RB. RA plus RB, the upward forces, equal to the downward forces, 2 plus 4, that is 6 kilonewtons. We have the value of RB. Can calculate the value of RA now. RA is 2.8 kilonewtons. RA is 2.8. Now let's check out shear force. Shear force is nothing but the resultant force acting at that particular point. So at A the shear force is nothing but RA. So FA is RA, that is 2.8 kilonewtons. At C the shear force is RA minus 2.8. RA is upward force and 2 kilonewton force is a downward force. So the shear force is 0.8 kilonewtons acting upwards. Now shear force at D is 0.8 minus 4, that is minus 3.2 kilonewtons. Here minus indicates that the shear force is acting downwards. Now FB is minus 3.2 kilonewtons. First see shear force FA. Shear force at A is 2.8 kilonewtons. That means that the force acting from A to C is 2.8, C to D is 0.8, D to B is minus 3.2. Now let's draw the shear force diagram for this. Let's draw the shear force diagram. Now first shear force diagram. Now this is point A, this is point C, this is point D, this is point B. Now at A the shear force was 2.8 kilonewton. Here at C it was 0.8 and the 0.8 and D to B the shear force was 3.2 kilonewtons. It's 3.2 here. So now this is the shear force diagram. See, this is 2.8, this is 3.2, this is 0.8. The shear force this gives the shear force distribution. From point A to C, the shear force was 2.8 kilonewton. C to D, the shear force distribution is 0.8 kilonewtons. D to B, the shear force distribution is 3.2 kilonewtons. So it's a shear force diagram. Now let's look at the bending moment. Now bending moment at A is 0, obvious. In a simply supported beam, the bending moments at supports will be 0. In order to be more clear, the bending moment is nothing but the moment of forces acting, the moment of forces about that particular point. Here the point A, so there is no forces acting. We are moving from left, so there are no forces acting here, so MA is 0. Now MC, that is bending moment at C. There's a force acting, reaction force at A, that is upward force. So 2.8 into 1, so 2.8 kilonewton meter. The units are kilonewton meter, as the force is in kilonewtons and distance is in meters. Now bending moment at D, that is 3.2 into 1. We have 3.2 into 1 is 3.2 kilonewton meter. Obviously bending moment at B is 0. Now let's draw the bending moment diagram. This is bending moment diagram. This is point A, this is point C, this is point D, and this is point B. The bending moment at A is 0 and B is 0. The value at C is 2.8, at D is 3.2. So this is the bending moment diagram. This value is 2.8, this is 3.2. Here the bending moments are 0 here. This is a straight line. Thank you guys, thanks for watching my tutorial. Please subscribe.